We're going to talk about multiplying radicals, and there's a few things you need to know before we go ahead and multiply radicals. First thing is that to multiply radicals, the index on each radical has to be the same. Next one is that we multiply numerical coefficients by numerical coefficients, radicands by radicands, and the absolute most important thing is when you get to the end, simplify if possible. Your answer is not complete unless you simplify it and put it in simplest form. So we're going to go through a couple of examples here to illustrate what's going on. Here, you'll notice the indexes are the same. They're both 2. And this is the square root of 8 times the square root of 8. Well, 8 times 8 is 64. So this is the square root of 64. It stays underneath because it was radicand times radicand. The coefficients here, even though they're not written here, are 1. So 1 times 1 is 1, which is still 1. Now the square root of 64 is 8. So there's a little trick here. You're going to notice root 8 times root 8, a radical times itself. When those radicands are the same, they simplify down, the radical is removed, and it becomes just that value. So root 8 times root 8 gave us the answer 8. If this had been root 7 times root 7, the answer would have been 7. So we need to keep that in mind as we're doing more multiplying questions. If we look at the second question, we're going to multiply our coefficients together first. 4 times 3 gives us 12. We're going to multiply our radicands together second. 6 times 5 gives us 30, and that stays in the radicand. Now the next thing we have to look at is we have to look at 30 and we have to see, can we simplify 30? Is there something we can do to make this smaller? Is there a perfect square that divides evenly into this? In this case, there isn't. In future questions, they will. Now the next question has some variables in it. Don't let it scare you. It's exactly the same as what we've been doing. Multiply the coefficients together. 4 times 3 is 12, and you multiply the radicands together. X times y is just x, y. Now, the next question, if we multiply our coefficients together, negative 2 times 5 gives us negative 10. And if we multiply our radicands together, 8 times 12, can't do it in your head, use your calculator, is actually 96. Now in this case, we can simplify 96. There is a perfect square that divides evenly into 96. 96 is 16 times 6. Remember, if you can't just look at this, get out your table of perfect squares and start dividing them. Divide this by 4, divide it by 9, divide it by 16 until you find the largest perfect square that divides evenly into 96. Now, this is the negative 10 times the square root of 16 is 4 times the square root of 6. Well, negative 10 times 4 is negative 40 root 6. And there's our final solution. So in this case, we are multiplying monomial radicals, a single radical by a single radical. But those aren't the only types of questions that you're going to see. We have binomials and trinomials that we can multiply out and simplify. Same process. We're going to multiply here. 1 times 2 is 2. Square root of 5 times square root of 10 is the square root of 50. Now, root 5 times root 5. Remember, when you multiply a radical by itself, the answer is just the radicand. Now, positive 1 times negative 1 means this is a negative 5. Then, we're not finished. The last step is always look and see, can you simplify the radical? In this case, 50 is 25 times 2. The square root of 25 is 5. So we have 2 times 5. 2 times 5 is 10. So this gives us 10 root 2 minus 5 as our final solution in this particular question. So you're essentially doing 2 multiplying of radicals. You're doing a monomial times a binomial, so you kind of had to do a little bit more work in this question. Here we're going to multiply a monomial by a trinomial. So we're going to multiply this by each of those terms. First of all, we're going to go 2 times 3 is 6. Root 5 times root 45, well 5 times 45 is 225. 2 times negative 8 is negative 16, and root 5 times root 5 is just 5. 2 times 3 is 6, and root 5 times root 20 is root 100. Now, if you start looking at simplifying this, 225 is actually a perfect square. If you take the square root of 225, it's actually 15. And 100's a perfect square. The square root of 100 is actually 10. So we get 6 times 15, which is 90. Negative 16 times 5 is negative 80. And 6 times 10 is 60. So when you work this all out, 90 minus 80 is 10, and 10 plus 60 gives us a final solution here of 70. Does it often work out that in a radical question, when you multiply it out, you get a whole number answer? Not often, but it works sometimes. Okay, here we kind of have a combination of things. We're going to have some multiplying, and then we're going to have some adding and subtracting going on. Here, 2 times root 3. Well, 2 is a whole number, and so that means it gets multiplied by the coefficient in front. So 2 times 1 is 2 root 3. 2 times negative 1 is negative 2 root 5. Negative root 2 times root 6 is negative root 12. And negative root 2 times 10 is negative root 20. Now, 2 root 3 and negative 2 root 5 are in simplest form. We can't simplify them, but we can indeed simplify root 12 and root 20. Root 12 is 4 times 3, and root 20 is 4 times 5. So we end up with 2 root 3 minus 2 root 5. Square root of 4 is 2, so this is negative 2 root 3 and negative 2 root 5. So in this case, positive 2 root 3 minus 2 root 3, those cancel out. And negative 2 root 5 and negative 2 root 5 gives us negative 4 root 5. We're going to do a question with some variables in it now. We're going to take negative 4 times 1 to give us negative 4. Root a times root a. Remember, when it's a radical times itself, it's just the radicand. Here, negative 4 times negative 9 is positive 36. And root a times root b is just ab. So we're done. That's the answer in simplest form. Now, the last example we're going to look at is finding the area of a shape, and in this case, we're going to find the area of this particular square in example B. So that means we have to take the length multiplied by the width. Now, what we're going to do before we multiply this out is we're actually going to simplify these radicals because they can be simplified. And oftentimes it's a good idea to simplify radicals first because otherwise the numbers get really, really big when you do your multiplication and it's tough. So we're going to do our simplifying over here. We're going to take 2 root 18 minus root 27. Well, 18 is 9 times 2 and 27 is 9 times 3. So the square root of 9 is 3. And 3 times 2 is 6 root 2. Square root of 9 is 3, so this is negative 3 root 3. So there's our binomial. And these two binomials are the same because you're dealing with a square. So we're going to take 6 root 2 minus 3 root 3, and we're going to multiply it by 6 root 2 minus 3 root 3. So in this case, we have to distribute. We have to multiply 6 root 2 by each of the terms in the second set of brackets, and negative 3 root 3 by each of the terms in the second set of brackets. So 6 times 6 gives us 36. Root 2 times root 2 is just 2, because root 2 times root 2 is root 4, and the square root of 4 is 2. 6 times negative 3 is negative 18, and root 2 times root 3 is root 6. Negative 3 times 6 is negative 18. Root 3 times root 2 is root 6. Negative 3 times negative 3 is positive 9, and root 3 times root 3 is just 3. So if we start simplifying this, 36 times 2 is 72. Negative 18 minus 18 is negative 36 root 6, and 9 times 3 is 27. So the final solution to this question, 72 plus 27, gives us 99 minus 36 root 6. So that's all we're going to talk about in multiplying radicals. Now we need to give you some practice so you can get better at this.